Hey everybody, this is Alex Merced from alexmercedcoder.com. And today we're going to talk about structs and methods. So there are usually in other programming languages, there's a thing called a class. Now, a class is sort of like creating your own type. So like there's type int, type string. Imagine creating your own sort of type that you can make as many variables of as possible. And you can choose what kind of characteristics it has, build in functions into it. This is sort of where object-oriented programming really comes in. I would create sort of, let's say, a dog class, and the dog class would have attributes like, number of legs, weight, age, name. Okay, and then we have methods like bark. Okay, which then I'd be able to make an individual dog named Sparky, name its attributes, and then tell it to bark. So that's sort of where object-oriented programming is. Okay, Go decide to go a different route, no pun intended. Okay, it's really hard to avoid programming puns as you describe programming concepts because everything is so semantic. But basically what they did instead is they just used another thing that you can see in a few programming languages called a struct. Now a struct is like a class with all the juice squeezed out. So usually in a class you can define methods and attributes, so basically variables and functions. In a struct, it's just variables. Okay, what you're doing is you're just creating a collection of attributes. But the difference between this and a map, okay, is that a map, everything you could have multiple key pairs, but they all have to be of the same type. Okay, so you can create a bunch of key pairs, all string keys, all int values. Okay, creating a key pair sort of array. With a struct, they don't all have to be uniform types. So a struct can hold a string for, let's say, name. It can hold an age, that's a number, and you can create all your attributes. But it's not like a class where you can define the functions when you define the class. You just define the attributes when you define the struct. So it's like half a class. Okay, so how would I define a struct? So let's make a struct. And what struct means is structure. So you're creating a structure that you can then create multiples of. Okay? So let's say I wanted to define a struct. So basically what you're doing is you're saying I want to create a new type. And we're going to say person. Okay, and that's a struct. And I'm going to say that this person has a name, which is a string. They have an age, which is an int. Okay, and that's good enough. We're just to get the point across. Okay, and there we go. So now I can actually create a new person like I would create any other variable. So I can be like var at Alex Merced is a variable of type person. Okay. And then I can and that's that. So then I can be like Alex Merced Alex Merced dot name equals Alex Merced, and then Alex Merced dot age equals 34. Cool. Okay, and then I should be able to just print out the thing. Format.print Alex Merced, and let's see what we get. So this struct is Alex Merced, age 34. And that's essentially what you're collecting a group of variables, essentially. And now this would be useful if I were like creating a video game. I wanted to create a hero with hit points and magic points and all the different stats you have to keep track of in an RPG, and then I just create a new hero every time we need to, or new villain, or whatever. But the thing is that that's essentially what you would do with classes in other languages, except the only problem is I can't create functions here inside the struct, aka a method. But you can give it a method. Okay, it's just done a little bit differently. It's just done the way you create a function. So you'd create the function outside of the declaration of the struct. So the function would kind of be worded like this. So I'm creating a new function. Okay. And then what I'm going to do is that we're going to say that P represents a person. Okay, so a person struct. Cool. So basically this function is going to be a method of a person. And then I name my function. So we're going to call this greeting. Okay, just kind of keep it simple. Or greet. And it's going to take no parameters. I could make it take parameters just like any old function if I wanted to. So that way when I call it, I'd have to put in a parameter, but I'm not going to. And basically just what happens when you call this function, fmt dot print. Okay, what I wanted to say is to say p dot name. So we're going to use the name of the person plus the string says hello. Okay. And then what I'm also going to do is I'm going to put a new, let's just leave it like that. Okay, and I'm going to comment out this print. Okay. And then that's it. There we go. So basically by declaring it that way, by declaring the type that is getting this method first and then defining the function, it now knows that this function belongs to that type, in this case, person. So now that I've created a person over here, cool. Okay, I can do this. Alex Merced dot greet, because it now knows that anything that's of type person has access to this function. And that's just, again, empty parentheses, takes no parameters. And what it should do, should say Alex Merced says hello. So let's see if it does that. Alex Merced says hello. So the way it does that is because when it calls greet, it's treating P as this individual person. So basically P, since this function is being called by Alex Merced, this P gets replaced by Alex Merced, so it's saying the name of Alex Merced plus says hello. And I can create as many people as I want. That's the beauty of methods. You can create functions that automatically have access to that individual struct's variables. Okay, you can do the same thing with just a normal function, and then you would just pass in the person as your parameter, and you still have access to all that information. This is just a more semantically pretty way of doing it. Okay, and then on top of it, if you're going to declare, if there's a bunch of other parameters, then you don't have to declare them here. You would just have to declare parameters that are not part of your person. So let's say we change this function to change name, and I wanted to give Alex a new name. So we're going to have one parameter, it's name string. Okay, and it's going to return a string. Actually, I don't need to capitalize that, string. And again, it's going to return a string. Cool. So actually, let's not return anything. Let's see if this works. Okay, so be p dot name equals name. Okay, and that's all it does. Cool. So again, I don't have to go put in the old name as a parameter to the function because it's a method, it already has access to that. So now, if I wanted to do that, Alex Merced, okay, let me get rid of this because the greet function no longer exists. Alex Merced dot change name equals Hector Merced. Let's try that. Okay, and then again, we're going to print out the struct right afterwards. So let's see here. Does that do what I think it's going to do? I can find, oh, typo. Oh, those are the best errors. They're the easiest to fix. Although, sometimes when you have a typo in the most unfortunate places, it can take you a long time to find it. So oftentimes you want to make sure you type it right the first time. Okay, so in that case, it did not change the name. So in that case, just like a normal function, that's what I thought was going to happen. Okay, that the stuff in the function doesn't stick. If we do want it to change the name, you have to use a pointer. Okay, so essentially the way we would just restructure this program when we write this function is you would change this to it not being the method of a person, but a method of the pointer of person, or something that points the person. Okay, change name, name string, that all is fine there too. And then again, we want to just change the value of the pointer. So let's change this. Okay. Just wait for a minute for the outside to quiet down, the sounds of Brooklyn. But anyways, okay. So basically what we need to do, we changed the function already, so that way it takes in a pointer to person. Now I just need to create a pointer to person. Okay, so we're going to create a, we'll call it AM pointer. So it's a pointer that points to me, which is going to equal the address of Alex Merced. There we go. Okay, so there's my pointer. And then I just need to change the function to AM pointer, change name, because that's now a pointer to a person object, dot, and then we're calling the function, which then I'm passing through the parameter, factor Merced, which then changes the value of the pointer name, so which should change the value of the underlying Alex Merced. So when we print it, it should have the new name. So let's make sure that all works. Let's see, invalid, indirect of type string. Oh, okay, let's see here. You think about that, invalid, indirect of p dot name. I think maybe let's see if I take off the pointer reference just because it's a, yep, that was it. Okay, because basically I'm not calling a pointer to the name. I'm calling the p is the pointer, and I'm calling the value dot name. So I don't need the asterisk in that case. Because I'm not calling, because it kind of already implies that. So p dot name. So again, when you're calling a attribute of a struct pointer, you don't need to put the asterisk to access the value, like I had to do before with pointers when I was just trying to get to the underlying value, when it was just a single int or string or whatever. Okay, so essentially that changes the name. So again, when I pass through the function, Hector Merced, it affected the pointer to the underlying and allowed me to actually make a change without having to do some assignment type, without having to return a value and then assign that value to I could change the actual item. So the function actually changed the name of the person, Hector Merced. So that would be how you would do that. So if you wanted to create a method that actually changes the attributes inside, you would use pointers in this way. You'd create a pointer to the struct, and that would just do that. Okay, so that's probably a little confusing. So let me just walk through this one more time to make sure that you have this nice and clear. Okay, so I want to create a function that changes the attributes of the struct. So I'm creating this method, but instead of structuring it as a method of the person type, I created it as a function of a pointer of a person type. So this is not a method of Alex Merced, it's a method of a pointer to Alex Merced. Okay, and what it does, again, the type, so it already has access to the AM pointer because it's a method of AM pointer. So the only parameter is a string, which is the new name I'm going to change it to. So it takes the pointer, and since the pointer is not, because whatever you send doesn't change, so the pointer isn't changing, but the pointer then points to the value that's being of where Alex Merced is stored and allowing me to access it. So then when I do name equals p.name, it's not changing the AM pointer. The AM pointer is still just pointing to an address in memory. So the function, as it usually does, doesn't change its input. But since its input refers to somewhere, and now we're messing with that place, it does change that underlying thing it's pointing to. So now Alex Merced is now Hector Merced after this function call. So cool. So basically what we learned is that you can declare a struct. So here's the syntax for declaring a struct. And you can create as many variables as you want in that struct. And if I wanted to give that struct methods like I would in a class in any other language, I just declare a method like so by declaring the type that I'm creating the method for before I name the function and declare its parameters. And if I want to change, if I want to make if I actually want to mutate the underlying struct within the function, then the function has to be a method of a pointer to that struct, not to the struct itself. Okay. If I'm just using it to, like let's say I just wanted to create the greeting thing, that could just be a method of the struct because it's not mutating the struct. So cool. So I'll see you guys next time. And this is Alex Merced from alexmercedcoder.com.